Good morning, everyone. And first of all, thank you all for joining us in this 2.5 days event. And can you see the screen now? I just put out the agenda on the screen.
Yep.
Okay, excellent. So we had hoped that this meeting would be the face-to-face meeting. If you remember, we talked about this at our spring meeting back in April of this year. But somehow the mother nature did not go our way, so then we have to hold another the virtual meeting again. Hopefully next spring, then we will have the face-to-face meeting, and we think face-to-face meeting probably much better in terms of communication and share this our knowledge to each other. This 2.5 days event is constructed in such a way that today we'll primarily focus on the pool fund study. So we're going to give you an update on what we have done and some major findings and also future activities. And so, but tomorrow we're going to have, let's put out tomorrow's meeting. So we're going to hear from the other states' experience and the results, and the New York DOT, Ohio, and North Dakota. They have been very actively evaluating this technology and collect some data from some projects, and so they're going to share their results on those project data. And also beside that, we're going to invite some of the contractors and some consulting companies who have done the data collection using the DPS system. And this summer, we'll hire the Matty Construction and the Ullman Brothers collect data for us. And so they got very good experience feedback to give to us. And also, I know this advanced testing collect data from New York DOT and Bryce Warrior, and they have collected a lot of data for different states. And also, Bryce has some ideas how to improve this data collection equipment. So there will be very good information from them, and I think their information will be help us to move forward in terms of implementation for the states. So tomorrow afternoon, we're going to hear from the Federal Highways perspective. Steve Cooper and also Dennis DeVolk is going to talk about this in the future. How do we move this technology into implementation? And they're going to talk about the implementation plan. And also, Dennis DeVolk is going to talk about this in the future. How do we use this DPS as a tool for the acceptance, at least to give us some ideas. That's for this 2 days events. But after tomorrow, we're going to have another 2-hour meeting back in the November 16th. So at that meeting, we invite some of the vendors to give the update on the equipment. So because for this technology to be fully successfully implemented, we need the vendor help, like replacement time, stuff like that, when the equipment breaks down in the field. So we're going to hear their perspective in terms of developing investment on this equipment. So that's going to be 2.5 days event. So any questions for me? Okay, if not, then I will pass on to Glenn to give welcome comments.
Thanks, Di. Hopefully you can hear me, excuse me, and see me. So my name is Glen Angstrom. I'm the office director here at MnDOT for Materials and Road Research. I have the pleasure of working with Di and Kyle and Kurt, etc. And this is a great, obviously a great effort I think we got going on here. I want to thank a lot of people. Federal Highways has been very, very supportive over the years. Dennis Dvorak specifically, Steve Cooper, of course, and Kevin Cleethemers from our local office. He's been really great. And Kevin is going to be leaving for retirement in January. So thanks to Kevin again for all your work over the years. We really, really appreciate it. You can't do any of this major efforts alone, and everybody involved is really helping move this forward. Speaking of that, all the state agencies, thanks to them, the manufacturers, consultants, contractors, academia, And again, finally, my staff for all the work you've done. Obviously I've been around for a while just looking at my hair color, but this has been one of the most exciting things along with all the other stuff we're doing with intelligent construction technologies. And we sometimes are slow to change as an industry for a variety of reasons. And we need to stay on this. This is a great opportunity for all of us to move it forward. I was thinking if you had to explain to your neighbor what you do and how you assure quality on a asphalt project, and you're explaining to them, well, we go out and we take these cores every so often, at least at MnDOT, and well, how often do you? Well, they're not, thousands of feet apart, whatever. And he says, well, really, is that how you do it? Well, we do have this other technology we're working on that we can scan the whole pavement. Well, why aren't you doing that? I'd have a hard time defending what we're doing now compared to the technology available. And like I've said before, we always seem to hold these new technologies to a higher standard than our existing technologies. And I understand that to a certain extent, but then again, I think every year that we put off using these new technologies, we're really, in my opinion, we're wasting dollars, and we never have enough dollars. Even though we're going to be getting more dollars, with the recent bill that's been signed, the needs will still outweigh all the funding that we do have. So I really want to encourage this group to keep looking forward and be that person at your agency that keeps pushing this technology forward, because it's definitely the right thing to do. And we're really close to getting it to use on all of our jobs in the future. And again, it's up to us to move this forward. So looking forward to the rest of the talks. Put together a great agenda, Di and Kyle, and this is really exciting stuff, and we can't be deterred. We got to keep moving forward on it. So thank you very much, Di.
Okay, thank you, Glenn. Yeah, we do get very good support from our management on this project. I appreciate for that. Let me share my screen. So the next one is my presentation. I'm going to give a general updates of the project. What I'm going to do, I'm just going to focus on what we have accomplished since our last meeting in April of this year. A quick recap of the project tasks. So as we know, we have identified 7 tasks under this project. So task 1 is the software hardware improvements. Since we're all using the JSSI equipment, so we'll contract this task with the JSSI. And task 2 is to develop national standards, the Astro standards for the data collection. That includes the field data collection as well as the laboratory calibration procedure, and also develop some of the standard method for data analysis. And task 3 is to develop the precision bias statement for this DPS technology. And task 4 is establish a certification program. And this will be very similar to the inertial profiling system that some states are using for the payment smoothness acceptance. So the thought in here, if we, once we get this DPS implemented for the acceptance tool for the density acceptance, then we need a similar program to certify the contractor's equipment as well as the agency's equipment as well. So task 5 is the support communication, and task 6 is provide any type of training or technical assistance to anybody who are interested in this technology and want help and some data analysis as well. So if you're new to this technology and would like to get into this technology and have some questions, just reach out to us and contact us. We're more than happy to help out as much as we can. Task 7 is promoting this technology. So as for the task 1, and so since April of this year, and the GSSI has completed 3 additional tasks. Task 4, 9, and 10 are done. Task 4 for the GSSI contract, that is to improve the data calculation methods. I talked about those issues in each of the tasks and the GSSI is working on, but I just refresh your memory. Task 4 is to like I said, task 4 is improve the calculation method, and the issue in here was that the old software took the run amplitude from GPR waveforms to calculate the dielectric constant of asphalt mixture material. For example, if you take your DPS system to try to get the density results on this structure, on this pavement structure, HMA over the concrete structure, and what we want is the refraction amplitude from surface, from asphalt surface. But sometimes the refraction amplitude from the next interface, from this interface, from HMA and concrete interface, has higher amplitude than this refraction amplitude from asphalt surface. Then the old software grabbed the run amplitude, grabbed this amplitude from this interface to calculate the dielectric constant of asphalt mixture. Suddenly that was wrong. So this issue has been resolved in the new software. So you will not have this problem anymore, supposedly. And task 9 is to come up the reporting mechanisms, and so that the user can look at the results right away after data collection is done. So they develop this data analysis reporting module, and this module is has been implemented in new software, and the results in terms percent conforming of density. And this is example, and this example is from the data we collected on this summer on the Trunk Highway 21. And this is a 1500 feet section. So the blue indicates the mag density results, and the orange indicates the joint density results. And the solid line, just take example on this blue solid line. The blue solid line is the average of density measurements for 100 feet section. So we take the 100 feet section as to report the results, but the user can select any length of the payments to report the results. So the blue solid line indicates the average. For example, to just take a first data point. The solid line indicates the average of that 100 feet section, but the dots indicates within that 100 feet section how many percent of the DPS measurements are within certain specified range of density. So in this case, we specified that the density range is 92 to 98%. So this blue dots indicates there were about 98% of the density of the DPS measurements were within the 92 and the 98% density range. So this way you can see there's on the 100 feet section, the density variations on the whole, on this 1500 feet section. If you take the whole project to look at, you can see the density variations on the whole project. So this gives you results, instantaneous results right away to look at how well your pavement is compacted. Task 10 is the failure indicator. If you used the old system before, you probably knew this. And the old system, there was no failure indicator. So during the data collection process, so this happened to us after the whole day data collection, and sometimes we found that's the data, and at the end of the day, we found there's some zero reading from some sensors, and also some sensors give the 15 or 12 this dielectric constant. So we knew these numbers were not right, but the operator did not know during the field data collection. So the new software, they implement this indicator module. So during the field data collection, if there's one sensor reads the dielectric constant out of the range of a typical asphalt mixture, then to give the warning. For example, in this case, one sensor probably read the dielectric constant 12, and so we know it's out of the typical asphalt mixture dielectric constant range. Typically it's 5 or 5.5. So there's a window pop up, and the operator should in this case should stop the data collection and check out the equipment. So all these new features has been implemented in the PaveScan 2.0. The new version just released it in the June, in early June this summer. But there's still 3 remaining tasks needs to be done by JSSI. There's 2, 3, and 5. And 2 is to improve the GPS accuracy. So the issue in here is the GPS accuracy under this DPS card depends on the speed of travel of DPS card. We found this issue by placing a metal strip under the ground, and we took the static GPS measurements, and then we pushed the DPS card across over this metal strip. And the DPS system records the GPS coordinates of this metal strip. So we compare these 2 measurements, and the moving GPS measurements is different than the static measurements. And there's offset, and offset depends on the speed of travel of the DPS card. The faster you travel, and the bigger the offset is. So we report this issue to the JSSI. I mean, they're working on this issue. And in the future, they're going to have another module in the software allow user to check the GPS system, the GPS accuracy on the DPS card. On task 3, that's the data management, and right now we still have to use the USB and the flash memory drive to transfer the data from the laptop used in the data collection in the field to the people in the office to analyze the data. But in the future, they're looking at some cloud feature to store the data. So then the operator and the field operator can load the data instantaneously to the cloud, and the people in the office can analyze the data right away, then download the data from cloud and analyze the data right away. So this will be very good for the probably real-time construction monitoring and data analysis. Task 5 is to provide some method for user to check the accuracy and the precision of the equipment. They provided us HDPE block, and if all the states have this new PaveScan 2.0, they should come with a HDPE block. And the HDPE block has the HDPE material has dielectric constant 2.35 around this value, but that is lower than the typical asphalt mixture, which is about 5 and 5.5. So they're looking at another material which has dielectric constant similar to the asphalt mixture, and as another way to check the accuracy of the DPS system. And all these 3 tasks are supposed to be done by the end of this year. As for the task 2, since April of this year, we updated the 2 videos, and one is the field data collection video, and another is the port calibration video, and used the new software and hardware as a 2.0. We created these 2 videos back in probably a year and a half ago. That was based on the old software and old equipment. So these 2 videos new videos has been uploaded to the DPS pool fund website, and this is the website address. Also, we recently updated the work plan. That's also under this website as well. And the new work plan has much more details in there and have some links to the publications and also presentations. And also there's much more detail. The budget is also under the work plan as well. Besides this, and also if you're new to this equipment and new to this group, and this website probably is a good place for you to check it out. There, along with this these 2 videos, the work plans will have the publications and also the presentations we have made in different conferences and meetings. They're all uploaded in this website. This summer, we'll continue our data collection by hiring some contractors. Previously, we paid the contractors to collect the data for us on an hourly basis, basically paid by the labor cost. For this year, we changed the payment method a little bit. Instead of pay them by hourly rate, we try to mimic the implementation phase. So we told the contractors, we said, go ahead, go by yourself to get equipment by yourself, either rent the equipment or whatever or buy equipment, whatever the method that you can get the equipment by yourself, and we'll pay you by the amount of data you gave to us instead of paid hourly rate. So we developed the data collection specification, and this data collection specification, we give this specification to the contractors, and we have the Urim browser and the Mati, these two contractors collect data for us. And so this method worked pretty good for the Mati because they own the equipment, but did not work well for the Urim browser. They didn't want to run the risk for this method to pay them by data method because the rented equipment from the InstruTech, they're saying that if it rains during the construction, then they cannot collect the data, but they still have to pay the rent. So they didn't want to take that risk. So we eventually were pay them by the lump sum of that project, of two projects. So we also got a very good feedback from these two contractors. We just had a close-out meeting with Urim browser, and we still need to hold a close-out meeting with Mati. But Urim brothers bring us very good feedback. And first of all, they like this real-time feature of DPS system. You can see the results right away after fence roller is done, after compaction is done. And also they brought up that it would be much beneficial for them if every roller has this DPS system, not only just on the fence roller. After the fence roller is gone, typically they probably knew there's some problem spot or low density spot. But if they had this DPS on every roller, and for example, on the intermediate roller, then they have time to correct it. And by that time, the mixture temperature is still high. They still have time to correct the low density spot, which is very good. Comment. Also, they brought up the safety concern. If you're using the person to push the cart for collecting data on the construction project, and sometimes the construction project is open to live traffic, and the person probably subject to about 12-hour, 14-hour and collecting the data on the project side. There's a long exposure to the live traffic, so that's the safety concern for them. And the equipment, the Urim browser equipment, broken down during the data collection one day. They had to wait about a week and a week and a half to get a replacement from the vendor, and they thought this take too long for them to get a replacement. If it is implemented as the acceptance tool for the future, and they cannot stop the paving process to wait the equipment. So they wished that the equipment replacement could be quicker, maybe just within the day or next day to get a replacement. So we have collected a lot of the project data and also collect a lot of the laboratory calibration data. We also develop different ways to analyze the data. And during the data analysis, we encounter some challenges. And I talk about the issue, like this verification core issue. And most of the time, the verification core results match well with the laboratory calibration line. But sometimes the verification course is on the one side of the calibration line is show the bias. So we need to resolve this issue, and also we need to develop some the acceptance criteria, because sometimes the contractors change the mix during the day. If mix changes too much, then the calibration line developed in the laboratory is not valid for that mixture on the field. So that's why we need to field the verification course to verify this calibration line established in the laboratory. So we need to establish how far away this verification core results away from this calibration line is considered acceptable, and how far away is not considered acceptable. We look at our data, and we felt we need some help from people with good statistical background, and also know this DPS technology. So we reached out to University of New Hampshire and the Isha and the Joel's group. They are working on the NCRHP ideal project. And this project is, the scope of this project is to use the DPS system to determine the box surface gravity of the Astro mixture. So they had to collect the mixture from different states and has done quite a bit of measurements on different materials as well. So without the database can be used for our project as well. So we reach out to them and we hope to establish a contract with them to work on our project as well. Carl sent out the work plan for the participating states to review, and hopefully you can give comments back to us by next Friday. I would appreciate. And also Ishan will talk about their work later today. For the tasks 3 and 4, as we know, the NCAT is working on these two tasks, and Dr. Fabrizio Leva is going to give some detailed updates on these two tasks, and they made very good progress on this project and these two tasks. The first thing they need to determine is the minimum lift thickness. And this is very important question to answer, because we got sometimes got a request from our district says, can I use the DPS to determine density on very thin asphalt layer? For example, this bridge stack overlay typically is the asphalt lift thickness is about an inch or sometimes less than an inch. Can we use DPS to determine such the density on such a thin lift asphalt overlay? So the NCAT compacted the asphalt slabs at the different thickness and also at the different density level and at the 18-inch by 18-inch dimension and for the two different mixtures. So the preliminary results they got so far is if the lift thickness greater than 2 inches, so basically there's no effects from underlying layer materials. But if lift thickness is less than 2 inches, and depends on the dielectric constant contrast between the two materials. If contrast is too big, and there is obviously effects from underlying materials, but if a contrast is not too big, and the influence from underlying materials is not that pronounced. For the equipment operator certification development, basically they need to develop two criteria. One is for the accuracy determination criteria, another is repeatability criteria. For the accuracy, basically you just need to compare the DPS measurements against the baseline value. If the DPS measurements is within a certain range of baseline values, and then you consider this DPS system is accurate. So in order to establish the baseline value, then the current plan is to use the nuclear density gauge to establish the baseline value. So they took the measurements, used the nuclear gauge and also non-nuclear gauge from. They gave us the update about a week ago, and looks like they have some inconsistency results between these two measurements. They're still in the process trying to figure out why the cost is inconsistent. For the repeatability criteria, so that's basically if you're using the DPS, same DPS system, take repeated measurements on the same path, and you look at all the measurements. If all the measurements within a certain range, then you consider this system is repeatable. So they're using the MEPDG and software, and they're using some of the advanced statistical methods to develop the preliminary acceptance score for both accuracy and repeatability. And Dr. Leva is going to talk more about how did they come up with these two scores. So eventually, they're going to develop an Excel spreadsheet very similar to the inertial profiling system, the Provo system. So the user just need to put the DPS measurements into this Excel spreadsheet, and then it come up with the score, pass or fail for that particular system. For the the precision bias statement. And so in general, they're going to follow the ASTM 691. This is a standard method for determining the precision of particular test laboratory test method. So they're going to follow general procedure outlined by this ASTM these standards. So this just started the round robin test. Currently, we have the NCAT lab and our lab, and also in this round robin test. And the Federal Highway, the HODAS group, also expressed interest to join this round robin testing. Doug Deliver, I think he's going to contact the HODA very soon for this round robin test. Task 5 is support communication. So we have the monthly meeting with Federal Highway and the HODAS group, and they have also actively in evaluating this technology. So we have monthly meeting to exchange information and fundings with Federal Highway. And also Steve Cooper and Dennis DeVoe visited us back in September. So we visited the actual project site and look at the contractors lab testing, and also visit the project site and look at the data collection. And that was very good for us too. And Dennis DeVoe gave us some thoughts on how to use the DPS in the future for the acceptance tool. We're planning at this time, the face-to-face meeting next spring, and we'll have to keep our fingers crossed, see if we can have the face-to-face meeting. And we talked about the face-to-face meeting for this meeting back in April, but it did not happen. But I think there's a highly likelihood that we can have face-to-face meeting next spring. Moving forward, we're going to have a technical working group meeting. At this technical working group, this idea actually came out from this Federal Highways, this implementation roadmap meeting. And Steve will talk about more about background of this technical working group meeting. And we're looking at, we'll have meetings with every 2 months. So it looks like we have a lot of meeting to organize, to facilitate. So we decided that we contract this meeting organization and also facilitation to a consulting company to help us to do that. So we reached out to CDC Associates. They are a professional communication company, provide professional communication services specialized in transportation areas. Also invited Brian Hurt from CDC come up and give us a brief introduction of the company and how they're going to help us in the future for organize this facilitate these meetings. And also they're going to develop the technical brochure for promotion of this technology. In terms of training and technical assistance, we will continue to provide the training, online training, anytime, anything you need from us. In our work plan, we said we can provide the on-site training. Looks like we can allow to travel now, but we have to get special approval, I guess, from MINDA top management in order to travel to out state. So if you need some online training, just contact us. I mean, on-site training, just contact us. But the Federal Highway Mobile Lab also provides excellent the on-site training as well. And Leslie McCarthy, she is manager of this mobile lab, and they have 4 or 5 the DPS equipment, and they can loan the equipment to different states for evaluation or collect the data. As far as I know, Massachusetts DOT, South Carolina DOT, Arizona DOT, Missouri, and Wisconsin, they all participated in this loan program. I think it has been working pretty good for them. In terms of promoting technology, and again, the Federal Mobile Lab is an excellent resource for promoting this technology. And we also make the presentations at different conferences and also our internal meetings. We will continue to promote this technology to contractors by hiring the contractors to collect the data for us. Moving forward, and the CTC and the UNH, they're also going to help us develop some brochures and the process flow chart for field data collection and laboratory calibration. And we're going to send out to the whoever wants this brochure, the contractors and some other states for promoting this technology. In terms of timeline and the budget, this is a 3-year project, and we're starting in January 2020. Officially going to end 2023. At this point, I guess we're still targeted to deliver this project by January 2023. You guys will have to see how the results, the initial results, come from the UNH the study. We may or may not need some time extension. In terms budget, we received about a little bit over $1.1 million from states and from federal highway. And the expenditures so far includes the money already spent and encumbered, and also our future plan for this project. Total is about 1.1 million. So we're within our budget. So budget-wise, it's pretty good for us. That's all I have. Any questions for me? I have 2 minutes left. Sorry.
There were a couple questions in the chat, but it looks like Kyle was able to address them in some messages responding to them.
Okay, good. Thank you.
Mm-hmm.
So let me stop sharing.
It's actually fine. I took control from you, Dai.
Okay. Okay, so Kyle will talk about our TPS, the new website, and also this work plan, like I mentioned in my presentation. Kyle?
Thank you very much, Dai. And yeah, I took a stab at the answers to the questions, but feel free to expand on answers there too, Dai, if you want.
Okay.
So, well, first of all, I want to kind of echo what Glenn was talking about. I was really impressed with the perspective he brought to this challenge that we're taking. People like Dai and I, we like to kind of dive into the challenges and figure out technically how to solve these different issues. But I think it is important as we go through some of these more detailed presentations to keep in mind the goal of what we're doing, which is a continuous non-destructive use of technology for density acceptance. And that's an exciting challenge, and I think it has a lot of potential to improve the paving industry and the life of the pavements that we're building. So this first 15 minutes, I just wanted to take a little bit of time to update everyone on what's going on with our website. The one thing that Dai mentioned in his presentation, he did a really good job of going through the details in the presentation, but we thought it was a good idea in talking to people like Kevin Cleathermos and Steve Cooper to have a nice kind of centralized document here that we can use. And that's something you saw. I was just clicking through the website to find it. I maybe should go back there before I go into the work plan. But basically, if you just go to the work plan tab and then select the live work plan progress report, you get this document here that every quarter we're planning on updating. In addition to our kind of quarterly reports, we just want to update each task so you have a little bit more background on what's going on with the project. And it's also a good place if you want to contact people. We have a list of the different agency technical contacts, and we have the background of the project. And what's new here is kind of the overall project funding snapshot and work complete percentages, things of that nature. And we also have that even broken down by task and then by subtask. So for example, we've gained some funds through the process of the work plan or of the pooled fund by adding states, and Federal Highway was able to add some funds for additional technical communication, this is the place where you can find that kind of information. And of course, you're always welcome to contact myself or Di as well. So one thing I wanted to go through also just to make you familiar with what's going on in this document is there's just too much content to put it all in one document. So what we basically do is try to point you to places where you can get additional information. So for example, if you're interested in some of the on-site training videos and you're not sure what's new or not, these are the places where you can go to see, for example, the new core validation module that we had presented on in the spring, and now this is the first season we implemented it. You can go here and watch these videos and see what's new from that point of view. And that's, you know, something that you could have always gone to the YouTube channel, but it's just nice to have it kind of in a centralized location there where you can see in what task are these different pieces of information available to you. Another thing that we'll go into here soon that I wanted to show you the link to is that it's also a good place where you can actually download data too. So when we talked about the analysis protocols down here towards the bottom, there's presentations where those improvements in the reporting mechanism is, but then you can also dig into the data too. So that's just a consistency check, and now we're getting to an accuracy check. But this is the example that that gives actual data from one of our projects. So this is our Highway 21 project, MnDOT analysis, and you have the presentations, but then you also have the Excel documents that support those presentations. So I would just encourage you to take a look at that document if you want information about the pooled fund in addition to contacting Di or I. We're always available, but it's kind of nice to just go online to find some of the stuff too. The other thing I wanted to point out that's new here is an analysis tab. And kind of the goal of this tab was to have something simple available, because one of the feedbacks that both the mobile lab was getting from the loan program and then pooled fund states were giving is it can be a beast to do this much analysis of all the data that we're collecting here. So we broke it down into the kind of most critical 3 sections, which is one, just checking the accuracy. So we give you a template where you can paste your data, and then we have an example just so you can see what the data should look like if you're using the template correctly. And we're planning on putting out a video on how to use these templates, and actually there's a few updates we want to do because the software's changed since we created these. But basically, if you put your information where there's green highlighted cells, you can get these sort of assessments that we're doing here at MnDOT, and this is just comparing the predicted density compared to the actual measured density that we're getting from cores. That is actually critical to the success of this method. And then it just does some simple things like highlighting it if it's outside of the spec that we'd like to see for that agreement between our actual core results and the predicted density that we get from our production mix. The other one that's huge that was a major issue initially, but the vendors have done a great job at addressing it, is a sensor consistency check, which is basically to make sure that your sensors are operating correctly. And again, it's a similar format as the last one, where if you download the example, you can see what the data is supposed to look like and how we're using it to check the consistency of the sensors. Let's see if this will open. And here, if you press enable content and then you paste your results from your swerve or your line test, then you can have it plotted over here to make sure it's within spec and it's broken down by where that actual collection occurred within the pavement. And then lastly, the summary analysis. This is the new one that actually, if you have the equipment, you should have gotten an email about this, I think last week. We've been evaluating a beta version of the software, but it's released now, where basically if you set up your settings correctly in PaveScan, when you do your summary analysis, it'll do all these calculations for you. So basically what you do is you take the on-site software and you paste the summary report here in yellow, and then you actually have a breakdown of what Di was showing you earlier, where you have both your kind of broken down 100 foot by 100 foot section, or whatever the user chooses to break it down in, both the median of your mat and your joint, and then also percent conformance. In this case, we're outputting what percent of the mat is within 93 to 99% density, and then what percentage of the mat is between 92 and 99 for densities. And that's these dots here up at the top. And we'll be looking at plots like this a little bit here throughout the day. Okay, so I think that's the only thing we wanted to hit on here for the website. Is there any questions about how the website is organized, or anything anybody wants to ask before we get into the next part, which is the update, or which is the current DPS protocols? I think I see one question in the chat. Surface reflection based versus velocity based are both giving the same value in what extent? Yes. Okay. Yeah, so we'll get into more details on that, Ulrich. But yeah, so Ulrich is asking about the example where we have dielectric to density conversion and accuracy. So he was asking surface reflection based, which is what we're doing in the field. So surface reflection based is the result we get for our dielectric when we're measuring behind the final roller. And then velocity based is the dielectric that we're getting when we're testing the production mix pucks. And the question is, are both giving the same value, and to what extent? And that is the question. And that's what we're getting most of the time. Yes, they are giving very good agreement, but there are still cases where they don't. And that's going to be a subject of one of the subjects of my presentations in the afternoon. So Robert says, I've found the website very helpful and understandable. Great job. Well, thank you. And will the final location of the website remain within the MnDOT domain, post-pooled fund? I don't know the answer to that question. So if anybody knows the answer to that, otherwise I'll have to get back to you, Mustafa, on that question. Oh, and thanks for the compliment too, Kevin. So it's 10 or 11:50 right now, so we still have some time for any more questions. If anybody wants to unmute and just ask a question, that's also an acceptable form too. So if not, I will close up the website and move on to the next presentation. So this presentation is titled Current DPS Protocols, Draft Astrospec. This is basically where we're at in our goal to have a Astrospec that can be used for taking DPS equipment and using it for density acceptance of HMA asphalt pavement. So what's been done so far with Astro specifications, we've had an equipment specification, and basically the challenge for that Astro spec is to make sure we have something that if somebody brings equipment to the to try to use as a DPS tool, that it can measure with the necessary precision and accuracy to be able to use it for density acceptance. Just a little bit of background on that without getting into too many details is it's been known for a very long time that probably since the mid 90s when Timo started doing work in Sweden, and Tom Scullion from Texas started doing work in this area, where it's very well known that an increase in dielectric is an increase in asphalt compaction. The challenge has always been having the necessary accuracy and precision of the equipment itself. And the SHARP program that Steve Cooper has initiated really showed an improvement from a technology point of view to be able to get those dielectric measurements to the point where they actually can start to be used for a density acceptance. So now the challenge for us is, okay, we know there's equipment that can give us that type of precision. We need to have an Astro spec in place to make sure that the correct equipment is actually used when you go out on a job. But one thing the spec that's out there now doesn't do is specify field use cases, and that's a subject for this pooled fund. And the PP 998-19 is published, but we do need to probably revisit and see if revision is necessary. And probably, I think that's the right place to put our spec for the velocity-based dielectric that we're using for our puck analysis. The pucks were not part of the picture when that original spec was published, but it does do a good job of giving us limits for if you want to bring new technology and use it as a DPS to make sure it has the right type of stability and all the measures we're speccing in that spec. And that brings us to the goal for the Astro spec we're trying to develop and refine as part of this study. The goal with this one is slightly different, where we want to specify a type of data that needs to be actually collected in the field, and it needs to be used for density acceptance. So we have to have the necessary checks in place to make sure that not only are you using the right equipment, but it's being used properly and in the right conditions to be able to give you an accurate density assessment. And you know, one thing to mention is that the goal of this specification is not necessarily to give us a specific density acceptance criteria. It's to provide to be able to check that you're actually collecting reliable density information. And I think the different states will differ in how they end up using this technology from a density acceptance criteria, but this is more of a spec to say, is your data good or not when you collect it in the field. And Rich Giesel in Alaska has done a lot of good work with the density acceptance criteria that you can use with all this mass of data. We're looking into percent conformance over 100-foot sublots, but regardless of what density acceptance criteria you end up using, you have to start with an accurate density measurement, and that's kind of the focus of this specification. So kind of the starting point is this DPS data specification that Di discussed a little bit in the work plan overview. And some of the major bullet points of this specification, you got to make sure your sensors are consistent throughout the day and throughout the project. So any changes in dielectric, it better be a function of the pavement you're measuring, not the equipment itself. So we have checks in place to make sure that the data is consistent. We also want to ensure that our conversion from dielectric to density is accurate, and it has to be accurate for the full range of densities and mix changes that might occur throughout the project. And that's where the production mix puck testing comes into play and allows us to be set up to be able to catch those changes in mixes, because, you know, technically speaking, this is measuring dielectric properties. It's not directly measuring density, and that's a critical aspect of use of a technology for density, is how you're converting from what's measured to what you care about. And then, of course, we want to ensure that the routine collection that's being used for acceptance is being done correctly and then with necessary coverage, which is quite easy actually with this technology, because it is continuous measurements and they can be done in a very tight spacing. And then it is a ton of data, and with other intelligent construction technology, just getting that data transferred is a critical aspect, because it does have important information, and getting that information sooner rather than later is a big aspect to the success of the technology. So the deliverables, we asked for pre-paving information from the contractor, just because with this, in Minnesota, we do our coring the morning after paving, and we run our random locations after the paving's already done. So we had to change that up a little bit, where we asked for pre-paving information so we could select or measure our random cores throughout the day. And my understanding is some other states do that anyway without DPS, but items B and C are specific to the DPS, where the projects folder contains all the raw field information, and item C, lab projects, contains all of the production mix puck information. And as Di mentioned, a software task is currently underway to make the cloud transfer of the data more convenient. So kind of the general outline of the document is we try to keep it as concise as possible, as digestible as possible for the contractors when they're reviewing it. So we ended up just referencing some of the protocols that you've seen come out through the pooled fund, and keeping the meat and potatoes into the DPS data specification itself. And the goal for Q1 of next year is to take this data specification and update it based on the feedback and experiences with it, take our existing protocols and update both of those, and then kind of meld it together into a draft Astro specification that the technical working groups can start to analyze, and we can get champions for various aspects to make sure that the spec is a sound way to get density acceptance out of a DPS. So I'm going to go through some of the each of the different portions of the data specification. As I said, the pre-paving information was basically to allow the agency to have information about where the cores are going to be located, and that way they could be marked, and a dielectric measurement could be made at the specific location where the cores are going to be collected. And we've been doing this for the last two construction seasons, with the goal being to be able to tell our districts and our contractors that we're not asking you to take any extra cores throughout the day. We're going to test the accuracy of our equipment using cores that you had to take anyway. And the goal moving forward, of course, is to start to reduce the amount of overall cores that you have to take. The field data description, it looks like a lot, and we made sure when we were talking to the contractors that the way that we need to spec this equipment is it needs to be easy for the operator to use in the field. And when we come up with our Astrospec, there's going to be requirements for a DPS equipment just in terms of ease of use. So if the equipment requires you to keep track of all these different things outside of their software, it's not going to work for deployment. So we just had a list of things that we need to know about the pavement, about where the data collection occurred and how the data collection is tracked, so that we know for every dielectric measurement that's made out there, we have all the necessary information to be able to use that in the assessment. So I'll be referencing these videos that we created this year throughout, and I'll just click on this one now, but I won't click on all of them throughout, but you'll have access to these presentations after we'll post them to our website. But basically these screenshots are from actual videos, so if you want to know more information, just go into these videos and they should give you a pretty good idea of what you need to be doing with your equipment for these various aspects. And they also came in handy when communicating what the contractors need to do, because it's a lot more intimidating to say I got to track all this stuff versus, okay, I have these kind of prepackaged inputs that I have to put in the software each day. So, and it's also been more convenient because they keep the actual values once you place them, because a lot of these things aren't changing either for an entire project or for multiple days. And that'll continue to improve, and we'll be able to rely on some of the experiences with the other intelligent construction technologies to try to make this as convenient as possible, so we don't have field technicians out there with a lot on their plate from a data management point of view. The field calibration data, we've been over this a lot, but these equipments all calibrate with a metal plate, and then they require an air calibration to get rid of noise. And what we specified in the spec was that this information just needs to be tracked, and we need to be able to go back in the data and see when the last calibration occurred. And this is just more for a research point of view, wanting to make sure we know what's going on when we're getting biased or inaccurate data. From a data specification and Astrospec point of view, I don't think specifying how equipment is calibrated will be the focus of the spec. It'll be more just these other checks that I'll be talking about later that tell us in practice if the equipment is actually working or not. So in the data specification, we basically just said you're only required to report your most recent air and metal calibration. The field dielectric quality check data. This is probably more aptly named the sensor consistency check, and this is basically our way as an agency, if we have a contractor collecting data, to make sure that that data is of the consistency and quality that we need for our assessments. And last year we required this to be done basically throughout the entire day, because the 2 years ago we had issues with sensor consistency quite a bit. I'll talk more details about this later, but we've seen much better consistency with our sensors lately, and kind of landed on basically making sure you do at the beginning and end of the day a sensor consistency check, and that can be either done with a swerve or a line test. And then we require the contractor to of course track and report those consistency checks. And just to give you a little bit of the rationale behind these consistency checks, this would be an example day where the sensors were within calibration in these red lines initially, and then our sensor 196 by the end of the day was slightly out of spec, and that's something that we kind of have to find the happy medium between requiring these consistency checks so often and making sure that we at least allow for what we're trying to do with the technology, which is give a good assessment of the mat and joint itself, because it can be time consuming to do these sensor quality checks. We also specified with the routine data collection acceptable patterns of collection, and this also included for this specific technology, giving a requirement that the sensors need to be spaced at 1.5 feet apart and at the vendor specified height, and we can talk a little bit more about the height requirement later, but the dielectric, it turns out, is sensitive to changes in height of the sensors themselves. And one thing we did with this, with kind of a simple tool that I'll click on here, is allow the user to go in here ahead of time, because each state might want to have different coverage, and as long as you specify your sensor spacing, you can kind of play with to see where you want your different passes to be, and this map over here gives you an indication of what the coverage is if you choose those different passes throughout the pavement. But for the specification itself, what we did is we broke it down into joint and mat passes, and we specified that you have to do at least one center line joint pass for it to be a complete 500-foot section, acceptable section of pavement. And again, we have videos showing what a joint pass looks like and how to set it up with the correct offset. And as long as they did one measurement at the center line joint, they had an acceptable joint assessment for that 500-foot section. We also did a mat category, and in this case, at least initially, we allowed the contractor to decide if they prefer to do straight line passes at the specified widths apart from each other, or if they wanted to do swerve passes, which are those data consistency measurements, but they also give us a good assessment of the mat themselves. But then in talking more with Kurt's pavements group and working with the data in Veda, the straight passes are much more convenient for that type of analysis. So we started to specify that they actually have to do straight passes in addition to the sensor consistency checks every 4,000 feet. So with this, basically what we ended up speccing was 3 passes back and forth for the contractor, where the first pass, they would just go down along the center line joint, and then second pass either could come back down the other side to get the shoulder joint, and then finish it out with a pass down the center. And this is the type of coverage that we get, where these 2 outside passes are our joint measurements, and then these passes in the middle are used for our mat assessment. And there's videos showing these different passes too. And that's what this slide basically gives us, is these different passes. If you have them at 1.5 foot spacing, gives you assessments centered along these offsets away from the joint. Our data specification also gave a field core accuracy check requirement, and this is what that question was before, which is basically, how good is our conversion from dielectric to density? And the way we spec this accuracy check was to have the contractor go out there and take dielectric measurements at each of these core locations before they're cut, and then compare it to our predicted conversion from dielectric to density that we got from our production mix pucks. And the accuracy of this fit can be observed visually, but then you can also look at the absolute difference between the predicted and measured densities, and that's in that template of dielectric to density accuracy check that I showed you on the website. The other nice part, we had showed you this new module in the software in the spring meeting, and now we were able to actually use it out there in the field, which is really nice, where you can actually specify which sensor you're using and do both a dielectric measurement at the core, and in Minnesota's case, and I'm sure a lot of other states' case, you also have a companion core that the agency will take to check the contractor core. So we're able to get two core accuracy checks at each location, and pretty conveniently with that software. So we specified that they did both a static measurement, which is to just sit right on top of the core location and take a measurement, and also a distance measurement, which is a new feature where if you start at the edge of where the core is going to be taken and roll it slowly forward, it actually takes really high frequency measurements over the core location. And we found this to be the best way to get your dielectric at a core location, and will probably be the one we use moving forward, this distance control. And again, in the video, you can see how to use the distance control measurements at the different core locations. So one thing just to note with the data specification is, as I said earlier, we wanted those field accuracy checks to occur real time as you're collecting behind the final roller compactor. But the logistics of core measurements proved to be pretty difficult. So on one of the projects, we were able to do it each day. But the other two, we had to do some, I guess, trials with this specification. And in this case, on TH21, we did allow the contractor to do a quick dielectric measurement the morning after the paving occurred, immediately before it was cored the next day. And if there's any sort of rain event the night before, which is these data sets here, you see a shift in the dielectric to the right, you can have issues if you do this type of if you allow this type of a core accuracy check. And the other thing is, we're doing our sensor consistency checks throughout the day when we're behind the final roller. Whereas if you're going out there and quick getting a measurement right before they take the core, if you have a sensor that's out of spec, you don't have a good way of checking for that within the time frame where you're out on the pavement. So, but the good news is that most of the days, even when we were doing our core accuracy check throughout the that project, we got pretty good agreement. And this is just breaking it down by 1,000 ton samples of the pucks that were used to create this curve, and then all the different days where we did our core accuracy checks. We did require a field GPS accuracy check, and the reason we do that is it's pretty critical, especially when you get close to the joints. So this is a alignment file where the purple pinkish line is the center line joint, and this is a swerve test where we're requiring no more than 1 foot within the paving lane there. And whether it's a joint measurement or a swerve, you can actually use the GPS data when you have a high accuracy GPS to see when the physical measurements are not where they're supposed to be. And so the way we spec'd the accuracy of the GPS was basically simple from a contractor point of view. They just had to take their regular static measurements at core locations, and we have GPS based locations at each of the cores, and we can just compare the measurement of the GPS from the DPS with the measurement from the GPS taken at the core location. And as I said in the chat, we saw very good accuracy. One thing I will mention is that one contractor had to use our equipment to get it compatible with the DPS technology, and the other one did get it to work with their own TopCon equipment, but it did take a couple weeks of debugging back and forth with the vendor. So the laboratory data description, again, much like the field testing data description, it looks like a lot in the spec, but the reality is it's automatically tracked as long as you have your inputs correct, and it's automatically exported just by pressing a button. And how to actually do that is in a YouTube video, training video we created this year. So so this is something that's got to be specified, but it's also our job as agencies to make sure we're specifying equipment that is able to make that as easy as possible for the actual technicians who have to record all this information about the production mix pucks. So the laboratory dielectric data, we asked the contractors to submit the results of both the first sample of the day. So for MnDOT, we have 1,000 ton sample sizes. So with the first 1,000 tons, the contractor would actually compact an additional puck. So they would do their normal design void pucks, but then they would also do a medium void puck, and they would also fabricate a high void puck. And we use that first sample to create our full curve. And then you can see here, there's more samples up at the design voids area. This is an example project where we got over 100 pucks throughout the project. And the reason we have more here is we basically had the dielectric testing equipment sitting in their lab, and their lab technician, just as part of their normal process, just added a dielectric measurement to their normal process. And that was really good for us because that allowed us to, in addition to having this full curve at the beginning of each day, track if there was changes throughout the day, because now we had a dielectric and an air void for every 1,000 ton sample throughout the day. So the actual measurement that we specified, we wanted them to do a top measurement on the top of the specimen, rotate the specimen 90 degrees, measure again, and then measure the bottom of the specimen. And the whole purpose there is to make sure that our sensors are consistent with their assessment of the sample, regardless of where it's testing it. And then also make sure that the sample itself is consistent. And after initial evaluation, we did, for logistical reasons, allow them to stop doing the rotate 90 degrees, and just as long as they got a top and bottom measurement and they were within the 0.05 dielectric criteria, we accepted it. And one thing we did observe is that the curve, luckily or fortunately, is very consistent from day to day, this conversion from dielectric to density. It's just if there's a pretty significant change in the mix where you might see a curve that's off of this line. And this was actually the first sample of the entire project. And their design voids, I think, were supposed to be 4%, and it was down at 2 after their specified gyration. So they did an adjustment to the mix, and after that, it was quite consistent from a dielectric perspective. I just wanted to touch on a few things. The advantage over the traditional way, starting in the 1990s, the way to convert from dielectric to density is to just take physical cores of the pavement itself. And the one nice part about the puck measurements is it's non-destructive. It's just adding additional material to make these additional pucks, or just testing the pucks that are already created anyway. And the other nice part is that if you're out in the field, you actually have to look for a low, medium, and high void location and mark it for coring, whereas with this process, it's a little bit more controlled in the sense that you can just gyrate to the same height and remove material to get the full range of air voids that you want. And truthfully, the dielectric that you get from a production mix puck is more stable than the dielectric measurements that you get on the surface reflection method in the field. And from that point of view, it does a great job of tracking the relationship between dielectric and any sort of changes that you do to your mix. That if you went with the traditional way, you'd have to core the pavement anytime there was a change in your mix that you thought might affect your dielectric. And we also were very happy with the contractor. They were able to integrate it basically into their normal laboratory process. And that was especially true for testing the dielectric of the pucks. They did ask if we necessarily need to have the medium and high void pucks every single day, which I think we will maybe be able to move away from and just start to test for dielectric of the design void pucks day to day. After you already lock in your full range of voids, you can just monitor the design voids to make sure there's no significant change in your mix. And then as Ishan's going to touch on, there is value in monitoring the mix with a dielectric property beyond just the calibration that we're using as part of our specification. Timing requirements. I talked about this a little bit with the core accuracy checks, where, you know, ideally we'd want to be doing these measurements for multiple reasons right behind the final roller, and that way there's no visible surface moisture. Typically, the mix is hot enough for it to evaporate, and your routine analysis can also be checked with cores real time that would allow for a quicker turnaround time to get information about how the density is going on that project. Less preferred, but we did allow for it in the current specification, was to address some of the logistical challenges with just having somebody collecting right behind the final roller all day, by allowing some trials of collecting the day after if it's a closed project, or doing the core measurement the day after. And it really, it opens up a whole new can of worms when you allow for testing after it's the pavement is cooled off, because now, as I said, any rain event or it could be debris pulled up onto the pavement if you're out in the country on a farm field. There's just a lot of different things that can go wrong if you're in a less controlled environment than when you're collecting right behind the final roller. In addition to having just the information quicker is nice to have. So we have about 15 minutes left, I think. So I did want to go through a little bit of the feedback we got from a specification perspective while we have time, and then hopefully we'll have some questions and we'll have time to discuss the specification from that point of view too. But the contractors, as with almost everybody, want to know what the plan is moving forward. So for example, Uland had to decide if they wanted to rent to buy, or buy equipment, and that sort of a decision for a contractor is difficult to make if they don't know what the plans are moving forward. Kind of our short-term plan is to do a similar data specification for next year, and the goal is to use a pay by section type of approach, and that may give incentive to the contractors to figure out how they can efficiently collect the data. And then also we need to make sure, you know, between research and pavements groups and MnDOT, what type of data we need for our, you know, we need to do our further research as part of the pooled fund, and the pavements group needs to make sure it's something logistically possible to deploy and convenient for our tool that we use for acceptance, which is Veda. And then once we meet that internal criteria, we got to get that spec to the contractors in time so they have the ability to turn around and get the equipment in a shape from a data collection mechanically point of view to be able to achieve the data and actually meet the specification needs that we specify. Just some brief challenges. The same day collection behind the roller, the labor aspect of it, you know, being long 14-hour days behind the final roller and pushing the cart. There was just some issues, so we're looking into some different ways of potentially maybe waiting until the paver's almost done for the day if it's a fully closed road, and then collecting all the data quicker afterwards. That's just something that's still being discussed between the contractors and MnDOT. Day after collection appears to be a no-go, at least in terms of challenges to the quality of the data that's collected. And there's a whole list of challenges with getting that core accuracy check. We want to make sure we're not putting extra cores out there on the pavement, but on the other hand, getting dielectric measurement on the locations where we're already planning on coring has proven to be somewhat difficult, and that's something we need to work with the pavements group and the contractors to you know, whether it's an extra 4 cores per day, we need to look at these different ways of getting those accuracy checks to put the technology to the test. And puck testing, as I said, it's going really well. We're able to get quite a few measurements, and I think we'll be able to pare back on that in the future in terms of what we're requiring from a specification point of view for puck testing. You know, one thing, the contractor and the district's safety is the most important factor, and the current push cart tech, pushing a cart with a person for the contractor, you know, one of them basically said they're only going to do full closures next year if it's going to be pushing, if the method is going to be pushing a cart behind the final roller, and it's just because of a safety aspect. So we've been trialing and showing some different ways, whether it's the moving bracket on the gator, or Steve Cooper had a good idea that the agency actually implemented towards the end of the year. We were collecting with a Segway behind the push cart, which helps with the data collection when you're walking 3-4 miles a day. Well, could be up to 10 miles a day because of the 3 passes. So the Segway was a good trial, but really the future is we got to get this stuff autonomous. And one thing that we were able to have at the end of the year, Jeff Brunner, our research manager, I think he found it on LinkedIn, was this tiny mobile robot. And this technology is currently deployed mostly for painting, whether it's soccer fields or baseball diamonds autonomously, but they're also getting into the pavements application with the robot. And kind of in parallel, one of the vendors also identified tiny mobile robot. So we had met with tiny mobile robot, and GSSI had met with tiny mobile robot independently, and we were able to get, GSSI had purchased one, so they brought it out to show us, and I took a kind of sped up version of the tiny mobile robot, basically doing exactly what we need it to do behind the final roller, which is basically go with your joint pass, come back and measure a few passes behind the roller in the mat, and then collect your shoulder joint pass. And so we were pretty impressed with that robot technology. And then we also have had some progress with the University of Minnesota that we're doing independently of the pooled fund, but obviously the results, if they work, we're looking to contribute to the different members. And this was actually a test last week by the University of Minnesota robot. And this one was just doing a pass 3 feet offset from the joint, then coming back 3 foot offset, and then a couple passes at 6 foot offset from the joint. And the difference with this one, it's actually collected with using the alignment file. So basically just inputting what you already have for the project ahead of time into the robot, you can just tell it what offset to go away from the center line joint, and it'll be able to achieve that. So we were happy to see a little bit of progress from the University of Minnesota, and I'm hoping we can get robots out on the projects starting next year to alleviate some of these safety concerns. But I will say, when we did bring it up to the contractor, they said, definitely, theoretically, they could even have the final roller operator start and stop the robot behind them. But we do need to consider that, live traffic could run into the robot, which of course it's better for them to run into a robot than a person. So I think that's kind of why this is a critical direction for us to try to get this technology as autonomous as possible and get people out of harm's way. So before I go through, I listed, just because we're going to have it available, a bunch of the specification debriefing comments that you can look up later, but I do want to take this last 7 minutes, if there are questions, to make sure I get to any questions that anybody has. And if not, then I can go through those individual feedbacks that we got from the contractor on the specification. Are there any questions from the group on the data specification?
There's nothing in the chat, Kyle, so if anyone wants to just unmute and ask a question, they can go ahead.
Okay. So if there's no questions, feel free to speak up as I go through these remaining slides, and then we'll get into University of New Hampshire's presentation. So I'll maximize my screen. One of the feedbacks we got, this is not necessarily specification related, is the equipment needs to be more rough and field testing proof. So they collected well over 250 miles of data, and if the equipment arm broke, for example, and it took a week to get to them. So the good news was, it wasn't like the vendor was trying to make money off of broken equipment, but the bad news was it needs to be in a quick enough time that if we're going to use this for acceptance, they need to have it almost same day to be able to deploy this type of a technology. And this just related to that, we're basically in the contractor's mind, maybe a testing equipment type rental company wouldn't be as good as a construction related company like a Caterpillar or a Topcon were two that they had suggested potentially the vendors need to partner with, because they're used to having to have stuff back in time to keep the paving operation going, which the contractor made the point, if this is going to be used for acceptance, this is really part of their paving train operation and needs to be supported like that. They could probably, we specified doing 3 passes, and they did say if it's a partial closure, they'd have to get it on a vehicle to be able to achieve that on some of the partial closures. The other comment was to get extra sensors so we could just do 1 pass, all 9 lines of data. And of course, there would be challenges there with the increased cost of extra sensors, but that might be something for deployment we just need to specify from the vendors to be able to get that 1 pass type measurements. They did get the rent to own option, but ended up not buying it. There was just too many things about the technology currently that was green in their eyes for them to invest in it. But they did like the idea of getting their hands on some technology and either using a golf cart or some sort of another arrangement to get the technology in a shape where they felt comfortable using it on a day-to-day basis without it causing any issues with braking or things of that nature. They did think the technology has merit, as Di said. It would be nice if we could get that information on intermediate rollers too. And a construction app would be useful. So they had, instead of just the technician pushing the device, other people on the project could see the real-time data. That would be very helpful. And we talked about the incentive to build their own way of collecting data, because as an agency, we're not in the business of creating those pieces of equipment. We just want to specify what data we want, and then they can provide the means of doing that. We were happy to get the feedback, and one message we're sending the contractors: don't be shy about saying what you don't like about the equipment. It's important for us to get that information earlier rather than later, before we already start to deploy the technology. And then I also listed, just Rebecca had sent a good email to the roadmap after the roadmap meeting, saying some of the things that both the bituminous office at MnDOT would like to see out of the technology, and the advanced materials unit would like to see, in addition to both of them together, as we push this technology towards deployment. And I put it here in the slides just so when we post these afterwards, you'll all have access to these, which I think are some pretty good points that we're trying to hit, at least at MnDOT, to be able to get this technology deployment ready. And then, of course, we got to make sure that with this specification, we're collecting the data we need to be able to figure out when the technology is working, when it's not, and figuring out, for example, that bias between field and laboratory measurements. When that occurs, what is causing it? And that's kind of a segue into our next presentation by Ishan, where they're going to join the team to help us out with some of these improvements that we need, just not from only reviewing our specification point of view, but also doing some statistical analysis and what needs to happen for this technology to get deployable for acceptance. So with that, I will plan on stop sharing my screen.
Kyle, there is a question in the chat box.
Okay. Okay. Ken Swedeen. Oh, Ken. Yeah, I had a good opportunity to talk to Ken early on when we did a demonstration in North Dakota. From experience on the demo projects where curve shifts occurred that were assigned to plant mix changes, were they asphalt content or bin split or type of aggregate changes? Great question, Ken. By and large, it's aggregate changes. So the source of the aggregate is the most significant change in dielectric properties. It's obviously a large portion of the mix itself, but then also there's large changes in dielectric properties, for example, from a limestone to a granite. Definitely aggregate changes is the most significant effect, but we're also, when we're going to be doing this statistical analysis, we're going to be looking at asphalt content and our gradations and things of that nature too, just to see if those kind of changes also have an effect. So good question. Thanks, Ken. And with that, we're 1 minute into Ishan's presentation. So Ishan, do you mind grabbing control here?
Sure, I'll go ahead and share my screen. Just let me know.
Yes, and so just to quickly introduce Ishan, we're very excited to have both University of New Hampshire and then also Adam Hand involved with this pooled fund. Ishan's been doing a lot of great work already with some of the laboratory aspect of testing pucks, and we thought this was a great opportunity for him to combine the work he's been doing and provide some of their expertise in looking at the challenges we have ahead for deployment. So with that, Ishan, I'll let you propose your work plan. And by the way, the feedback I've gotten so far on the work plan is very positive. So the other team members are happy to have you guys join the team.
That sounds great. So thank you, Kyle, and great presentation, by the way. It was really nice and very, for me, very educational. Learned many things. I will mention that Professor Sias is actually PI on this project. She's connected now. She had a class right before, so that's why I'm really shepherding this presentation. But Joe jump in as needed on this presentation. So I will try to keep it short because I know I'm somewhere between your lunch and at least for several folks. For Rich, probably between breakfast. But anyways, so the presentation here, I'll just talk a little bit about the work plan that we have put together in discussions with Kyle and Di and understanding what the needs are. It's also a good segue with all the topics that Kyle mentioned, all the needed areas that are to be filled in as we try to take this excellent technology and approach and try to make it into a more and more of a routine thing and acceptance criteria. So as Kyle mentioned, it's really an effort between us, and we also have Adam Hand serving as a consultant on this, or hoping to have him serving as a consultant on this subcontract, especially with his experience with coming from industry and now in academic setting. With a lot of experience on QA processes, will be very helpful, and that's why he's part of the team as well. And I should make a quick shout out to An. An is connected as well. He's our star graduate student who's been working on the all the different stuff that we have done with density profiling system. And actually, An comes to us from MnDOT. That's where he was working before starting his graduate studies with us. So just quickly, why or what we are trying to do. So as you saw from Kyle's presentation, there's substantial amounts of data that's already been collected as part of this pool fund effort. And what we are hoping to do is take that data and really run it through rigorous statistical checks in order to help refine some of the protocols, but at the same time also improve the specification to the point where it's a statistically approved or statistically backed quality assessment tool. So that's really the overall objective here. And to achieve that, we have really identified 5 thrust areas. First one is just to get everything organized. So that's really development of a master database that has all the field as well as lab measurements that have been collected as part of this pool fund study. There are some additional steps in there that I'll talk about when I discuss the task. Second side is really to help more of a refinement of the protocol of establishing that curve that we've all looked at so many times, and we had some discussion just in this previous presentation of what all things can impact that curve and how reliable it can be. So really it's refining that protocol and developing the relationship between dielectric values and density for a mixture. The third aspect is to do more with how we can use statistics to make sure that what we are collecting is relevant and reliable. And that really talks also about sensor bias issues that one might see, as well as challenges with data variability, especially when you are doing these multiple passes, or even for whatever else reason there are variabilities that might get introduced into the data. The fourth objective is to really package all of these previous things into something that helps with implementation, because at the end of the day, we don't want to just develop these specifications or refine the methods, but we want to convert them into something that's practical and easy to implement. So that fourth objective is to develop a data processing tool, something straightforward like Excel-based tool that can run all these checks and all the statistics for the user. And if any of the red flags show up, it shows them so that the process flow is standardized or process flow is streamlined. And then lastly, as with any project, we obviously want to also develop materials such as maybe recorded webinars or other type of reports, memos, things of that nature that helps take these research activities, take the outcomes of those activities, and help put them into practice. So how we have these objectives satisfied is through a number of tasks. First task is obviously gathering all the data, so collecting all the data that has been gathered so far. Running some quality checks. There are standardized methods that we can follow to make sure that there are no mislabeling issues or things of that nature, typing issues on project names, things of that nature, as well as do statistical checks on collected data, especially on the lab data, using things like outlier analysis to make sure that all the data that's used on subsequent or within subsequent tasks is reliable and does not have any kind of errors into it. The second task is to focus on how do we determine or how we evaluate sensor bias when you are doing the field measurements. So in this case, we will again use all the data, especially MinDOT has collected a lot of data with different strategies to address sensor bias, such as swerve data or transverse line. Other agencies have tried a few different things as well. So we will use those data sets, put them through again statistical testing to develop two things. One is when the overlapping data is acceptable and how one can check for sensor bias. But not just that, what we also want to provide is how often one should be needing to do these kind of specialized testing, such as swerve or transverse line or any other strategy, in order to know that you don't have a sensor bias within your measurement system. So really the outcome here is not only provide the analysis tool where you plug in the data and says, yes, you have sensor bias or no, but also recommend how often those kind of checks should be conducted. So that's the second task. Third task is really the correlations between lab and the field dielectric measurements. They use different techniques just because of their nature. So here we will do a multi-level analysis from a very fine granularity to a more of a project level comparison. So specimen level comparisons, you are really comparing cores coming from a specific location and the DPS measurement in field from those same locations, lot level analysis, project level analysis. And again, the objective here is to continue to look at how can we improve the lab to field dielectric interconversions and simultaneously how can we improve the protocol on how we are currently measuring the lab dielectric values to develop those curves, which are essential because those are really what allows us to go from the dielectric measurement to your density measurement. Now the great thing is University of New Hampshire with Joe as PI has an ongoing effort. It's NCHRP IDEA study that has really that is really focusing on refining and improving the lab dielectric measurements, and that's really the focus of that study. Near the end of this presentation, I'll just give you a glimpse on what we are doing there. But the great thing is there's a really good opportunity to leverage all the effort that's going into that IDEA study, and vice versa. The data that you have from the pool fund also is helping that IDEA study, so that this really formalizes that sharing of information and corresponding improvements on both projects. Task 4 is very critical in my opinion. It's really the task where we are to formalize a method. Well, two parts. First, use all the existing data that you have to identify variables that can cause a systematic difference, whether it's a gathering or data collection direction, joint versus middle of mat, moisture, sensor height, whatever you may have. So really do a large scale correlation testing or statistical testing to identify any variable that can have a systematic impact onto your measured dielectric values in the field. Once those variables are identified, also try to put them into corresponding buckets so that we know which of these will need a categorization prior to measurement. In other words, you may, based on our first step, we might identify that there are these three things that should be categorized in the data that you are collecting, because at a later stage, it might be relevant to know that information. The second part that will come out of this data variability analysis is to also know at what point you may want to take a core. So at what level of variability or what level of these variable changes might trigger a need that a core should be taken, and you cannot only rely on your scans at that point. And then the last piece of the same task is to provide recommendations on, and you actually saw this point in one of the contractor feedbacks that Kyle went through, at what point you have sufficient amount of data. So at what point you say that, okay, on this project, on this day of paving, this many square feet of pavement surface or square yard of pavement surface or this many feet of scans have to be done to be relevant. So that's really trying to answer the question as to what is the extent of coverage at which your results are relevant. Obviously, with DPS, we are scanning a lot more than what we do with cores that are taken at individual points, but nonetheless also provide some recommendation on, do we need to scan every square inch of your pavement surface, or can you have a representative amount of measurement that can then be considered reliable from perspective of a QA process. And then lastly, what should be the recommended frequency for accuracy checks in order to continue to validate that calibration curve? So how often you may have to do a ground truth type of core measurement to do your accuracy check. So that fourth task is really critical, especially from perspective of taking this technology and this approach and then trying to move it into something that really changes how we try to control quality today and move into this future. Fifth task is putting all of these developments into a single solution. We'll try to do it with an Excel-based tool, but if we are trying to do some advanced statistical modeling or testing, we might have to rely on other tools. So we don't know yet as to what that tool will be. Our effort will be to do it within Excel, just because people are more familiar with it. We are more familiar with it. We have prepared other tools in past for other applications. So the idea here is to have a product that we can then give to anyone who is using dielectric profiling system or density profiling system, that then tells them, okay, you have sensor bias or not, or it gives you different kind of flags when there is a need for accuracy check, or whether there's a need to maybe gather more data or things of that nature. Task 6 is to take all of this information, put it into a draft specification or draft specifications, and then the final report. I will say it's an ambitious timeline, but that's what we have really in terms of the amount of time left on the pool fund. So I know we will be very busy with this project. There's no two ways about it, since most likely by the time we get contract in place, we are looking at start of next year. And our hope is to wrap everything up by end of next year. So it will take some significant lift on our end, but we feel optimistic that we are able to deliver it. So I will just take a pause here for a moment and see if anyone has any questions or comments on this. And Kyle, I don't know how I'm doing in terms of time. I still have 5 more minutes of stuff just to talk about the idea study, but I can skip it if we are pressed for time, so just let me know. And since I'm sharing screen, I only have one screen here. If folks have questions, I may not be able to see them. So
would you be willing, Ishan, what if we had Lauren give instructions on what we're going to do at the end of this to prepare for the afternoon session now, and then for everybody who's interested, we can stay after for the rest of your presentation.
That sounds great. I'll stop sharing for in the meanwhile for Lauren.
I don't see any questions in the chat as of right now. I just wanted to remind everyone to exit out of this meeting once we're done, and then come back into the new meeting in an hour when we're ready for the second session to start today. That was all I had for a reminder.
Great, thank you very much, Lauren. And just another reminder, make sure you actually leave the meeting because that'll end our recording too. So once you're done, please leave this meeting and then enter the new one. So please continue, Ishan.
Sure. So hopefully you can see my screen again. And as I said, this will just take, won't take very long.
Yep, you're good.
Okay, perfect. So as I mentioned, we are also leading a NCHRP idea study. It's a study that's focused on trying to take the lab dielectric measurement system, which really came out of the pool fund, but try to formalize it into a draft Astro test specification, which means that we have to do a whole bunch of ruggedness evaluation. We have to evaluate what all can impact your lab dielectric measurements and test it and determine what would be the extent of that impact. And also as part of this effort, we are trying to build at least a preliminary version of a relationship to try to link your dielectric constant to bulk specific gravity of mixtures. So develop some kind of model where you might have to put in some inputs like geological source of your aggregate and gradation and so on, and try to build that curve, or maybe at least build a curve if you only knew one point, for example. So instead of having to do multiple points to generate the curve, can we generate that curve with only one known point or no points? So that's really the later part of this project. But the part that we are working on right now is really the first 3 points, which is how to make this lab measurement system rugged and robust and practical, so that it can be used on routine basis without worries of any kind of precision issues or bias issues. So in terms of tasks, we have project broken in 2 stages. First stage is just establishing the measurement reliability and drafting the test procedure. And we have already completed first 2 tasks, and I see a lot of people on this call who we have bothered quite a bit in getting these materials. We worked with Kyle to identify specific agencies that are part of pool fund and try to contact them and gather mixes from them. We have already collected 16 different mixtures that represent different type of geologies of aggregates, gradation going from 4.75 all the way up to 37.5. So really a wide range there. With these mixes, we have gathered enough material that we can try out all kind of different variables, such as thicknesses of specimen, or whether you have cut faces versus as compacted faces, or even if you can, whether you can test differences in the diameter of specimen as opposed to always using a 6-inch diameter. What if you have specimen that are slightly different in sizes? So all the material collection is done. Anne is working feverishly on task 3 and 4, where you'll see in a second we are doing a lot of testing on these specimens and simultaneously doing statistical analysis. The second stage will really kick in next year, where we are then going into that model development on Can we predict bulk specific gravity if we knew dielectric value and other informations about the mixes? So that's where we'll also do component material testing and use some advanced data analytic techniques. So just to give you a glimpse of the extent of measurement, Anne has been doing 160 dielectric measurements on every single specimen. So that's the level of detail that we are using to make sure that we are capturing every possible way of doing a measurement and finding what's the least amount of measurement that one can do and still get a relevant result from a single puck. And that includes things like testing on one face versus other face, different orientations. Even at the same orientation, we are trying to do 5 measurements, trying to somewhat establish a repeatability type of measure where the operator is same, but just loading sample back and forth and seeing how that could have an impact on the measured quantity. Just some of the data that Anne has collected, just to show you that everything's looking as expected. The only difference between what you saw on some of the previous plots today as opposed to this is each of this point is actually 160 points. So again, it's a tremendous amount of measurement effort that we have done to ensure that we are capturing and documenting what's the maximum variations that one can encounter when doing this dielectric measurement in lab. And then obviously as your material sources change, as you have trap rock, that's what Connecticut used on that project versus granite versus limestone. So as you have different sources, you obviously have different trajectories. But it was also interesting to see all of these Massachusetts and New Hampshire projects. They are all using granite. The Massachusetts are 37.5 millimeter mixes. The New Hampshire's half-inch mix, and it's quite impressive as to how closely they were lying on top of each other with the trends there. What did we find so far is preliminary. We are still working on this, but the first one is unexpected. Is expected. We knew we would see this, but as you have more and more air void content in your mixes or into your pucks, and a lot of these are at 12-13%, that's when you usually see higher variability. That was expected. The second thing we found is in future, Anne doesn't need to do 160 measurements on every sample. We have shown that just doing 5 measurements with 3 orientations that are 120 degrees apart, you can do it whichever way. You can do 3 on one side and then flip the sample and do 2 more. You get statistically representative answers for those samples. Now there's something that we are continuing to explore to make it even simpler because 15 measurements are still quite a few of measurements. But at least we have already went down from 160 to 15 on what we are doing now, with the hopes that we'll be able to bring it further down. So that's really all that I had, and I apologize, Kyle, if I took too long as compared to what you had planned.
That was perfect. Yeah, as Kevin, I think Kevin Clethermis just said, and I agree with, the work adds huge value to the future direction of DPS. So we're really happy to have you guys part of the team.
Thank you very much.
We do have another question from Ulrich. What is the thickness of the pucks you are testing? Are they all the same thickness?
No, and Joe already beat me to it. So we are really going from as low as 50 millimeter to as high as 180 millimeter. Our baseline is 150 millimeters. So that's or 100 millimeters, I should say. That's what you would typically get as part of your mixed design pucks. But no, yeah. So very good question, Ulrich. And we are going from as low as 2 inches to very high thicknesses. The highest thickness is more to do with a specimen that people typically make in lab for performance testing. So that's why we are doing those. So hopefully that answered your question, Ulrich.
Not to put
but
you
on that
spot,
plot, they were all comparable thicknesses. Yeah.
Okay, that's what I was going to ask, because I think Ulrich, he can expand if he wants, but they have thinner pucks, I think,
Yeah.
or less thick pucks than what we've been looking at. So if the shorter ones also work well, that'd be a huge finding, I think, for them.
Yeah, and I can give you one glimpse. I'm stealing An's thunder here, but I'm excited about it because we just got these results in last few weeks. But we already showed that whether you have cut faces on your pucks or as compacted faces, we are really seeing statistically same results. So and that's big again. May not really impact your day-to-day construction mixed design type of work, but if you are doing, for example, performance testing type of work where you have specimens that are cut out of field cores, or even your gyratory samples cut and then measured for density, we wanted to make sure that that's not introducing a bias.
That's great. Ulrich, did you want to expand on that, or did that answer your question?
I think he answered my question. I was really interested to know if the thickness will have any kind of different impact on the reading, because we used to test 62 millimeters puck, and we started doing 115. And for it seems to me like there is a slight difference, but I'm not sure. That's why I'm really interested to know.
Now that's very good question, and we have not gotten to the thickness effect part of our evaluation yet. So I believe that's one of the next variables that we are going to be taking into account in this. But good to know at least that now that we know your experience, that helps.
Yeah, thank you. Yeah.
Well, thank you very much, Ishan and Joe. Like I said, it's great to have you guys part of the pooled fund moving forward, and appreciate also being able to share the results of your other really important study with what we have going on. So, oh, Brett doesn't want to eat lunch. Brett Williams says, are you varying specimen temperature when testing?
No, we are not varying the specimen temperature as of right now. There was not one of the variables that we had. However, in some recent discussions that has come up, we'll try to see if we can at least do some small scale experiment to look at it. But right now, everything that we have done so far is in a single temperature, in a temperature controlled room type of situation, which is all at room temperature.
And one thing I can add, and I'll present a little bit on it later, is we did do a small scale test varying specimen temperature. So saw very little effect, a slight increase in dielectric with temperature, but not very significant. So, but that'll be good if you guys are able to either confirm or figure out what your experience of temperature is too. But I'll present a little bit on that later. Brett, good question. Okay, well, a lot of good interest in what you guys are working on. So that's a good segue into lunch. So everybody enjoy your lunch, and we will see you in the afternoon. So join the new meeting link, the new meeting invite this afternoon. We'll see you all there. Thank you.